Hello, our team comprises of Abhishek Nair and Priyanshi Furia, and we have worked on the problem statement of machine learning, which is real-time language translation for niche languages, and we have went with Indic languages. So presenting to you Indic Translator, bridging linguistic divides in the digital age. So yeah, let's take a look at our problem statement. So, as we all know, India is a linguistic diverse country, and there's over 22 official language spoken by which is officially recognized, and there are over 19,500 plus dialects. There are 121 minor languages which are spoken by over 10,000 people. And by another census report, it said that only 10% of Indians speak English fluently. So there's a digital language divide. 70% of the users that use the internet on a day to day basis prefer their content to be in regional languages, whereas only a fraction, which is 0.1% of online content that we read, that we interact with daily, is available in regional languages. And we also can see that 90% of new internet users are non-English speaker. So why do we need Indic language translation? So there is a $53 billion e-commerce potential with regional language support. The amount of reach that we can get with while just by incorporating the regional languages where more people can feel inclusive and can access the content which is only available in English. 75% of Indian internet users prefer product info in local languages. This is essential for the Digital India initiative's inclusive growth. So let's talk about our project goal. So we want to develop a high quality translation system for Indic languages, achieving real time translation across multiple platforms. It should be web, it should be to translate any website, or it should be at the comfort of your phone. Create a user friendly interface for web, mobile, and browser extension. So, key features of our project. Our project includes a text to text translation wherein we input the text in English or in any Indic languages. We support over 22 Indic languages, and then it could be translated into any of the English or any of the another Indic languages. There is a speech to text translation where we can speak into our system and then it will translate it into any of the languages. Then there is a document translation where we upload our document and it will translate the content and then just provide it to us. And we have also developed a Chrome extension for easy page translation, web page translation, a part of the page, whatever you're reading on your day to day basis, you can just select it, click a button, and it will be translated in a second. So let's talk about the approaches that we have tried to come across this. So first approach was a sec to sec, sequence to sequence model. So we implemented an encoder decoder architecture and we collected the data. There was a huge corpus of parallel data. We have collected over English to Hindi, English to Marathi, English to Gujarati, and various languages like that. So the issue we face with this was it needs a lot of data to train these large language models, and that was something we lack. So and how computationally expensive this was to train this model, and given the limited time frame, it was really hard to get the result that we were hoping for. We were able to train a few model and we do have it on our GitHub, so of course we can have a look at that later. So yeah, this was our first approach. Then going to the second approach, which is FairSec. This is utilized by this is developed by Facebook and it is known as Fair Sequence. So this improved handling of the long range dependencies, which was one of the shortcomings of sequence to sequence model. So this was a much better model, but still it was not up to the mark like what we were expecting. So you can just take a look at the architecture of the FairSec model. So this basically has a forward embedding, a self-attention block, normalization. Then you feed forward it to the next layer where it is encoded and decoded, and the output is decoded to us. So let's look at the approach that we have implemented. So we made use of a pre-trained model by AI for Bharat, which is known as Indic Trans V2. This supports over 22 Indic languages. It has multilingual support with shared vocabulary between all these languages, making it really useful for real-time languages wherein the corpora is shared and we have a firm idea of what we can work with and how we can like have a real-time translation, and it is so lightweight. It is optimized for CPU performance. It can locally run on your machine, and we are also trying to implement it in edge devices. So the technical implementation. So we have a Flask-based web application. Then we send real-time translation API calls to our backend. We have integration of the Indic Translator model, a speech recognition model, and a PDF parsing. And we also have a translation pipeline with it. So yeah, these are the features that our project contains, and we will talk about this in detail while we take a look at our front end, and we'll just discuss it along with that. So this is the landing page of our app, and now let's take a look at all the features that we have implemented. So this is the first text-to-text translation model where we can select our source language, then we can select our target language from any of the 22 Indic languages. Then we can start typing. As you can see, it supports real-time translation. So it translates as you type. So now let's take a look at the second model. So in this, we record an audio, it gets transcribed at the backend, then it gets sent to the backend for translation, from where it fetches it and displays it on our screen. So we can select our source and the target language as usual. Then we just press record and speak what we want. Hello, my name is. Yeah, so it will show the transcribed text here. So as you can see, it got translated, and now let's take a look at our final feature, which is document to text. So what this basically does is it takes any text in the document, it extracts it from that, and then it translates it to any of the target language that you choose. So you can choose any of the PDF file, and you can just press scan. So yeah, so as you can see, it transcribed what was in the document into the target language. Now let's take a look at the Chrome extension that we have made. So basically you can just go here, Indic Translator, you can select your source language and then your target language, and you can select any of the text. So like I just selected this, and you just right click it, translate selected text. So as you can see, it shows translating, and then you get the translation in the middle of the screen, and then you can just close it. So as you can see, we have a very comprehensive logging in the console. So these are the features that Indic Translator currently provides. So let's talk about the challenges that we overcame during this hackathon, so and that we faced during this project. So it was balancing the translation quality and speed. We had to ensure that the translation quality was up to the mark while also maintaining a really moderate inference speed, and one that could even be run on a CPU bound machine or even in a GPU bound machine. So the another issue that we faced was handling various index scripts and languages. So all the data sets were scattered all around the place. We had to collect it, we had to decide which languages we had to work with, and then we had to create architecture for each of the models. So that was pretty challenging. And then we also integrated multiple features as we just showed previously, which is the text to text, speech to text, PDF, and then the Chrome extension. So what are the potential application of Indic Translator? So we can use them in our e-commerce website. We can use them in education sector where students might benefit from it. We can use them in government services where there are many people who don't understand, who prefer regional language over English. And then we can use it in media. So to conclude, I would like to say that this project represents a comprehensive solution to bridge the digital language divide in India, which is at large. By developing such a high quality translation system, it addresses the needs of millions of internet users who prefer regional language over English. The project aims to enhance accessibility and inclusivity. This initiative not only supports the Digital India vision but also unlocks significant potential in various other sectors. Thank you.